ready to go? Great. So welcome all. Hope you're enjoying the first day of Rhythm World. And thanks for attending our session. Today we're going to be talking about data science and security analytics. I am Dr. Phil Villela, Chief Scientist, one of the co-founders of LogRhythm. And I'm joined today by Dr. Daniel Kozlowski. He's our team lead, one of our senior data scientists. And what we're going to try to convey to you today, there's the obligatory headshots, we'll just skip past that. What we want to convey to you today is we're going to talk a little bit about LogRhythm's Cloud AI platform. This is a new cloud-based service that we launched last year. This is where we are implementing and exercising some of our more advanced analytics use cases. And I'd like to talk about the role of data scientists in that build-out. I will then turn it over to Dan here, who will talk about specifically the UEBA use case, so user and entity behavioral analysis, as well as some of the futures that we see for our Cloud AI platform. Great. So Cloud AI, what is it? It's a word, it's got AI in it, but what are we building here? So Cloud AI from the beginning is something we viewed as a general purpose analytics pipeline, right? So we didn't set out to build a UEBA analytics pipeline. We set out to build a very general purpose and highly scalable analytics pipeline that would allow us to add additional use cases in a very modular way over time, with UEBA being sort of the first use case. Over here on the left is the LogRhythm SIEM that we're all familiar with today, right? So I've got my on-prem platform managers, processors, data indexers, perhaps one or more AI engines, and they're doing the job that LogRhythm does every day. Critically for Cloud AI, they're collecting all of that data and processing it into a very highly normalized and structured format, which is that metadata that we've all come to know and love. That processed metadata is forwarded up to the Cloud AI platform. I'm not going to spend a whole lot of time talking about the technology, but I do like to call out, it's on Google Cloud Platform, right? And we leverage two pieces of technology there called Dataflow and Apache Beam, right? The reason we chose these very quickly is because these technologies provide what we believe is sort of best in breed in a modern streaming and batch processing platform. And it takes some of the concerns of building out and running that type of platform off our hands, right? These things auto-scale and they fan data out and parallelize it for us. That's not something we want to spend our time worrying about. That's becoming a more commoditized concern, right? We want to spend our time solving security analytics problems, for you. And so when that metadata comes up to the Cloud AI platform, one of the first things we're going to do is have simple filtering and pre-processing, right? We might want to select out certain types of data. For UEBA, that would be things like authentication and access data. So that's the first stage. And then in the second stage is where a whole lot of thought work has been done. And Dan's going to talk a little bit more about that in detail. But this is where the data scientists really are in their keep. And that's in determining what the features are that characterize the thing we're trying to analyze, such that we can model it and then evaluate future activity against it. So in this stage, we extract the numeric, quantifiable values that we're going to model and then measure real-time data against. We save those off to a database. In this case, it's Elasticsearch, because that's something LogRhythm is very familiar with and scales very well for our needs. We can then take those features and we can build models. We can build a variety of types of models using a variety of types of algorithms. Again, Dan will speak a little bit to that. But suffice to say, what comes out of that, for example, in the UEBA use case, is a characterization of your activity on the network. The systems you come from and authenticate to and what locations, etc. So now that I've got a model, I can use this exact same pipeline, and it's critical that it's the exact same pipeline because the live data has to come in. Those same features need to be generated on the live data. And now I can start to ask my model questions. Does this data fit the model, right? Is this user's activity consistent with what's gone on before? And in that case, we're doing something we call anomaly detection. I'm trying to detect outliers, behaviors that you or one of your users are exhibiting that are not in line with previous behavior and activity. In the UEBA use case, we will then pass it through a stage, what we would call normalization and scoring, right? I want to quantify everything this model or maybe a collection of models is telling me about that behavior and cast it in a way that gives you sort of a prioritized look at those users. Who's most anomalous today, for example? So I can start an investigation there. And then finally, we pass those cloud AI events back down to the SIM. So they are available as events or, almost like logs in your SIM, such that you can build dashboards on them. You can pass them through AIE and combine additional analysis with those. So let's talk a little bit about data science's role in that. So we've got this platform that is exercising that. So what has the data scientist done? So I always start out by emphasizing this, and it's the old saying, garbage in, garbage out, right? This is a primary concern of analytics. We leverage the machine data intelligence that's built into the LogRhythm SIM, right? LogRhythm has spent 15 years building up probably the most comprehensive knowledge around devices, their context, and the content within those. And we leverage that structured and consistent data normalization in our analytics. You really can't do analytics without starting there. And so that's key. Next is that feature engineering. And Dan's going to talk quite a bit more about this, but what feature engineering means is we're going to fuse our knowledge of the data. Again, LogRhythm's experts in their MDI, and we have security experts in our MDI. So we're going to fuse that knowledge along with analytics approaches. What types of models do I have available to me? And are they going to effectively answer the questions I'm trying to answer? As well as domain expertise, right? We're security people, right? We're going to inject domain expertise into understanding how to build those features. And that's what we feed into statistical and machine learning methodologies, right? So for the most part, this is where data scientists spend most of their time. Figuring out what those quantities are that I'm going to model that characterize user behavior, for example. So approaches to behavior anomaly detection. So there's a whole variety of different types of models out there. And I know today machine learning and AI is a hot topic. It's a bit of a buzzwordy area. But suffice to say that we operate within some constraints that guide us in selecting those. First of all is the availability of training data. Right? There's two regimes of things I can do in machine learning, supervised and unsupervised learning. Supervised simply means I have been provided with labeled data, right? Here are examples of good behavior. Here are examples of bad behavior, right? I can then use certain class of methodologies to train that up and then pass new behavior through it, tell me whether it's good or bad. In many cases, we don't have labeled training data. How many of you have very comprehensively labeled data that tells you exactly when it's good, bad, or other, right? Very, very, very few. So we use unsupervised algorithms. That's one of the things that guides our choice. Accuracy, it's not accurate, it's not going to be useful. So that's just fundamental. Efficiency is huge. In cloud AI, we're talking about building per user models, right? So if you start to do the math and say like, okay, LogRhythm's got maybe a few thousand customers. Each one of those customers might have 1,000, 10,000, in some extreme cases, 100,000 users. That's a lot of models that I've got to build up and a lot of evaluations. So they've got to be efficient. They've got to be able to scale. Some models are easily parallelizable. Others are not. So that guides us. And then again, something that I think gets skipped over a bit is what we call user consumable attribution. When a model or a methodology has bubbled up what it believes is very anomalous and said, I believe this user's activity is anomalous or bad, one of the first questions you ask is why? Why do you think that? Right? Some modeling techniques are not very amenable to that. Tell me why you chose that. Others are very amenable to that, and so we want to balance there. We want to choose things for the most part that allow us to convey to you why it made that decision it did. And then finally, we chose to do this in the cloud as a cloud offering, one for these scalability concerns, but also one of the important things is data has to be in front of data scientists for us to build effective models. We need to be able to understand when those models need to be retrained or changed. And so that was critical in our decision making there. And now I'm going to turn it over to Dan to dive a little bit more.
Great. So thanks, Phil. What I want to do is I'm going to echo exactly the same points that Phil just made. But what I want to do is dig in just maybe one level slightly deeper into what we're actually doing in cloud AI. This is important for us to do, we believe, because we are taking a rigorous scientific approach to solving this problem. There's a lot of hype, I sort of mentioned it in the little blurb of the ballroom. There's a lot of hype in this field. The more that we can tell you about what's going on here, the more we feel trust we can build, and the more friendly of a system that we'll be able to offer to you. So that's really my goal here in sort of demystifying some of what's going on here. Okay, so there are many use cases that Cloud AI is built and engineered to facilitate. The first one is the UEBA, User and Entity Behavioral Analytics use case. So I want to focus on that one for the time being. The key word here is behavioral analytics. Let's take a stab at defining that for a second. Cloud AI is consumes a stream of logs sent up to it from the SIEM. No single log can define a behavior. Instead, behaviors are sort of subdivision of all the activity that are inside of these logs along very specific dimensions. So what do I mean by that? We consume log metadata. There will be various log metadata fields that correspond to authentication behavior. And so we will extract those fields across the logs that we see to build up the authentication behavior. Similarly, there will be metadata fields that describe the set of machines that a user is authenticating from. That will go towards the origin host activity. There will be metadata fields that describe the machines that a user impacted host activity. We will get geolocation information, and from that we can talk about distances between those locations and build up a picture of the location activity or location behavior, again, across all of the logs. And similarly, every log has a normal date or a timestamp to it, so we can begin to analyze temporal patterns. So in that way, I like to think of this as sort of funneling down from the sort of broad to the more specific categories or behaviors. Okay, so that's all well and good, but this is a machine learning product, so how do these get fed into a machine learning model? At the end of the day, a machine learning model simply wants a matrix of numbers. It wants numbers to crunch. So our job here, and Phil touched on this quite a bit, is to do feature engineering. Let's unpack this even further. You can think of a behavior as sort of a logical grouping of features. Features are just a numerical quantification of something that we see in the data. So I want to take just a minute to talk about the types of features that we'll build, or the categories of features, and give some examples on each behavior. So looking at, let's choose, say, impacted host activity. Some features are just easy and simple aggregations from logs. The count of the number of unique hosts that you have accessed seems like it would be pretty informative as to the impacted host activity. That's all well and good. We can get a little bit more informative. Let's say that we see authentication to host A 19 times in an hour, and host B 0 times in an hour, host C once, and so on. Well, that has a certain variability pattern, and we can use statistical techniques to quantify that variability. So we start to build up a picture in a numerical sense, in a very quantitative, you always get there, quantitative way for each behavior. Other examples, we are a security company. We have in-house security experts, so we leverage what LogRhythm has built to sometimes give just obvious security relevant features. We're looking at authentication behavior. The number of failed authentication attempts might be security relevant. Similarly, we can leverage what the LogRhythm SIEM gives us and look at the common event that is stamped on every single log. The common event is essentially a LogRhythm classification of what went on. Were you accessing this machine over RDP? Was it a graphical login? Again, I can start to analyze the variability in the different classifications and start to build up a numerical quantification of what's going on. And these are all types of things that can actually be fed into a model to spit out an answer for us. We'll just touch on one more in the interest of time. We can take a slightly different lens to this and look at this from a peer-driven perspective. Many of you are here from out of town in Denver. Let's say that you're based in Minneapolis, and most of your logins therefore come from Minneapolis. Today, however, you are anomalous because you've been logging in all day hopefully not all day, but you've been logging in from Denver. That may look to a model to be quite unusual. However, perhaps you're here with 3 of your colleagues who also are now beginning to log in from Denver. So in isolation, you may appear anomalous to a model, but if we can leverage peer information to understand, well, yes, you are deviating, but your peers are also deviating, so maybe this isn't as severe, or maybe this isn't notification worthy. Things of this. Cloud AI can begin to make those determinations with peer-driven information. Aggregations also facilitate temporal pattern analysis, where we might just look at the sheer volume of activity in any hour of the day and determine, hey, I'm a night owl, I do all my work at 3 a.m. Phil's not, he does his work at 3 p.m. And if I started doing work at 3 p.m., well, I also do work at 3 p.m., but you get the idea. So this is how we numerically quantify what is going on, what your behaviors are, that all originates from log metadata sent up to Cloud AI. Okay, so we've talked quite a bit about feeding data into models. Let's take just a small amount of time to talk about the models themselves. This could be an entire hour-long talk, and I ran over last time, so I'm going to go over this really, really quickly, but we can take questions offline if there are any. We can build up a statistical model of what is probable and what is improbable by looking at those features we just talked about across time. So when I take those features and look at them across time, this is built, we built up a multi-dimensional behavioral baseline, where each one of those quantities that we just discussed might be represented by a different color here, and maybe I'm looking at this over 30 days or a year. And so now I have some history, some pattern to train an algorithm with. So a statistical model might say, hey, I've seen this before. It's very probable. It's very likely. Whereas, oh, I've never seen this, right? Or this blue one has a huge spike in it. And it can tell you, well, you're not very probable, but, and return a very high anomaly score. Similarly, we can learn compressed representations for data. So you can think of this as learning representative building blocks for your data, which means if I see data today that looks like your history, those building blocks I'll be able to build it out of those building blocks. However, if your data no longer matches your baseline, those building blocks, no matter what configuration the model tries to put them in, simply can't represent what it's seeing now, and so it can flag that as anomalous. Finally, and very briefly, we mentioned peer analysis. When I take each multidimensional behavioral baseline for every single user and cast it into this peer space, so to speak, I can then use a nearest neighbor algorithm to say, well, here you are, and here are your closest neighbors. These are your peers. These are the people that you should be behaving like. And when you stop behaving like them, or when the set of peers changes, that can also be flagged as anomalous. And so these are the types of models that we leverage in Cloud AI to try to build up a comprehensive picture of these behaviors and behavioral analysis. Okay, so let me very briefly come back to what Phil started with, which is the platform that we built, our cloud analytics platform. We have spent a lot of time building up a highly scalable and robust pipeline to facilitate these analytics. Why is it important to get the pipeline right? Well, before you have a machine learning problem to solve, you have a big data problem to solve. And a great example of that is, okay, great, we've talked about the UEBA use case, but you've also heard a lot at Rhythm World about network traffic and NTBA. Well, the sheer volume of data involved in a network traffic analysis is likely orders of magnitude larger than the UEBA use case. It's really important that we've built a pipeline that will be able to auto-scale to handle that volume of data. And it's also important that I don't have to worry about it, so I can continue to work on the models. So that informs some of the decisions that Phil touched on in the very beginning. Exactly like I just touched on, an important role of data science here is to be continually evaluating the efficacy of models. I might put a model into production that you are seeing the end result of that's based on a few assumptions of the distribution of the data. It's very important that we have a pipeline that allows us to monitor that, because as soon as that assumption is wrong, because the model becomes stale, you're getting less than great results. And not only do I need to be able to monitor that, but we need to be able to build automation into that to detect when a model needs to be retrained or updated. Finally, you may have heard about the true identity and true host constructs in the SIM, where a log may come through that doesn't have an identity assigned to it, say network traffic, but perhaps we can use statistical inference, whether in Cloud AI or in the SIM, to stamp the most probable identity on it, and then data that couldn't previously be run through our UEBA models now can, because it has an identity attached to it. So that was a very, very quick introduction to some of the things that you'll be seeing in the future from Cloud AI, all because of the again, highly scalable and robust pipeline that we've spent a lot of time building out. So if I've left any time for questions, I'd be happy to take questions.
You have left 10 minutes for
Oh,
questions.
look at that.
All right.
All right.
Is this kind of like automated threat hunting on steroids in a way? Because you're looking at all these indicators of compromise, and I'm just trying to like, I mean.
Yeah, I would
this is
characterize
big,
it
I'm just
right
trying to
now
simplify
is
it.
where we are with a lot of this is starting to build insight into user behavior. Something that I do, so I log into our internal logarithm deployment every day, right, where we have Cloud AI running this. And partly because I'm responsible for the data science team and I want to see how things are working, but also because I myself want to build insight into what's going on the networks. So at this point I think it's providing two things. One is, what are my users doing? What are the most anomalous users doing? Why were they anomalous? Those are the types of questions I can start to ask and answer from Cloud AI. And then finally, it gives you another sort of angle to approach threat hunting. Because I can log into Cloud AI every day, and I do this exercise because this is sort of the typical exercise. Who was most anomalous yesterday? All right, let me just go look at that user. Why was he anomalous or she anomalous? And then I can start to drill down through that data, leveraging the web console and the other capabilities of the SIM platform to really start to characterize, okay, they were coming from, I can see their modem. I can see their activity through the Palo of them VPing in. I can do whois lookups, and I start to build a picture around why that was anomalous. And frequently, you can visually see it. And visually, as we say, you can frequently trip on, say, somebody's password expires, and they forgot and left it under on their phone or some other device, and so I see a nice pattern of successes, and then suddenly that drops, and I get a pattern of failures. And so one of the powerful things this is doing is building insight into what your users are doing.
Do you have any examples, any dashboards that you have?
Yeah. All right, so let's talk a little bit about what you actually see in Cloud AI. That's a good question. So this is from our internal deployment. I've fuzzed the faces to protect the maybe not so innocent, but as you can see, what I have here, and sorry, it's grayed out because I'm highlighting there, but here is the user anomaly score distribution for a day, right? So I can see a whole bunch of people piled up down here from 0 to 30 or so, not so. Again, one of the exercises that I go through, and it would be a threat hunting exercise, let's go find the most anomalous user. There's 2 of them with the same score, and you can see I picked out that first person there who I can actually see from their title as a technical product manager. So
What
he's
they
at
do.
this meeting today, so we know who it is.
Can you tell us who it is?
No. I'll point him out later. And so now I can drill down into that score and ask and we call these what are the timeline events that made that user anomalous in that scoring period? So I can see that there's unusual login activity. Specifically, some of the things I'm drawing out of this are, I'm seeing that there was 7,800 authentication attempts where 60 were expected. So what I'm getting is there's a characterization here that a peer deviation, a large number of authentications to a specific host, an unusual pattern to impacted hosts. What I start to build a picture of here when I was looking at this is this person's authentication activity has just exploded for some reason, right? It was pretty normal. Somebody authenticating 60 times or 28 times in a day, maybe not that unexpected, but this has been a huge jump. So I can combine the timeline events that I'm seeing with the quantities to get a little bit of an idea.
I was going to wait for you to finish. But I seen a similar dashboard with something like Exabeam, for instance, right? It looks really similar to this. What are you guys doing that's a little different than what they're up?
Well, primarily, so one of the things I'd say is that differentiates from Exabeam, and this goes back to the beginning. We typically, as a data scientist, we don't talk about algorithms, right? I can use 10 different algorithms to answer the same question, probably with equal effectiveness. What it goes back to is comprehensiveness of data and the structure of data. And so I think one of our strengths and one of the things that differentiates us from other UAVA vendors is the breadth and depth of data that we can bring into this. And so as you say, from a point standpoint, you can see some of this looks similar. When you start to talk about logarithm platform and Cloud AI integrating with, Exabeam is trying to build a SIM now. right? They're starting to build their SIM now. We've spent 15 years building a SIM.
Is this available now?
This is available now. We launched this last year. Yep.
So is it a separate dashboard from what I had currently? have?
Yeah, when this is enabled, you'll get a Cloud AI tab up here in your web
And
console.
I'll just add like a 2-second add on to that is one common misconception that I've run into is that this is meant to replace parts of the logarithm platform. That is not the case whatsoever. This is
Right.
very much complementary. And so when you start feeding these cloud AI events back through AI Engine to correlate that with something that you've seen, I think that's how you really leverage the power of the entire platform here.
You next?
Yeah.
So you mentioned retraining the models when they become stale.
Yep.
Do you conceive a time when you would be able to run those retrospectively? So for example, if you, right, okay, so if you...
That's absolutely a roadmap ask, is that, hey, and even with AIE, there's this ask sometimes, hey, I've discovered something, I've written a new rule, I want to run old stuff through it. And for this, it's almost even more important, because one of the things we want to do is, right now, we've got to baseline you. We've got to accumulate data over a period of time. What we want to get to is, all right, let's maybe go out to your data indexers and say, feed me the last 30 days of data, so I can start modeling and answering questions tomorrow. So that's,
So, right now, this is all just for the cloud. Is there a plan to somehow try to adapt this technology for those that are not cloud connected?
so it's a very good question.
Because it seems to me that it
Yeah.
should be transferable.
So it's not something that's not like on our very immediate roadmap, but what I can tell you is those technologies we chose, specifically Apache Beam, we are writing this pipeline in Apache Beam because it is capable of running on multiple, what they call execution platforms. So Google Cloud and Dataflow is one of them, but Apache Flink and Apache Spark are others. So if at some point we wanted to offer this full capability in terms of on-prem or private cloud, you would be able to bring up those execution engines and run this pipeline. Now again, that's a roadmap item that's kind of
You said the operative word.
mid to low.
Baseline you.
Yes.
And I see real value in this helping me
Yeah.
to build my baseline on my air
Yeah.
gap system.
Yep. And we understand there's a tension there for some folks who can't get to the cloud. It's just the ask we're making of the platform in this case, it has really mandated that in some
Yeah.
cases.
Yeah.
Yeah.
I think we were just getting the sign.
Yeah, yeah.
We might be up here. Be around the rest of the event.
Yeah,
Come
absolutely.
find us, ask
Find us
questions.
if you have other questions.
Thank you.
That was good.
Yep. Appreciate your attention. Thank you.
Come find us, because that's absolutely something that's core to what we're doing.
It's gotta be based on that, so.
Yeah.